Okay, so the next step will be to learn like kind of the different sections of a post-processor. So I'm gonna close that for now. I don't need this and that. I'm gonna just look at no, in fact I would like to keep the last one, so I'm gonna just re-post-process it. Okay, and split left. Okay. So first, when you have your post-processor, generally you will have a default header. So now I'm using KUKA's post-processor to show you. I will switch to another post-processor. They are all kind of using the same structure, but have but are adapted to the different language that the robot controller uses. That's kind of the concept. Like the post-processor is a translator. So you will generally have a default header. So this is what will appear on top of your program. So as you can see here in the default headers, you have global interrupt, blah, 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 fold, some base, some other stuff, a fold here with a quick access to the access actual. You have a go home here folded. And if you look here, you will see that all of those lines are simply copied from there to here. So if you had to change the header and you would like, okay, I want to have something else here in the header that always appear, you just come in and you just change the header. So if I was like to come here and just say, this is a test, updating the header here. Control S, right click, generate robot program, and then here in the new generated program you have this is a test. I'm updating the header, so what I added here was directly sent here, so I'm gonna save that here. Then you will have here a bunch of flags or global variables that will impact the behavior of that given post-processor. So here, let's say you have first max line. So here you have a limitation. We already talked about that when we talked about the options and parameters of the tool option programs for generating programs. So there was a limit here, there was a checkbox. So some post-processor use that one, some use the value here. I know it's confusing. I do agree it's confusing. I don't know why we're doing that. I'm not responsible for that, but that's how it goes. So sometimes you just need to modify here. So here the limit of lines is number of lines limited to 2,500. You have here include subprogram if you want to include the same program in the same file. Subprogram as a file if you want to generate subprogram as separated file. You will have KRC version here, so if you want to use KRC4, KRC2, you just change that or comment one of those lines. Skip message pop-up, doesn't matter. Let's say here you have the program extension, so by default RoboDK will generate an SRC, which is what we are expecting, but here we can change the extension if we want, instead of generating in .src here. Program name length, so we will limit the program name to a certain number of characters. So for the KRC2 it's 16, for the KRC4 it's 24. That's something that you kind of need to know from your robot documentation, but we kind of take care of that already. So here it's you have an external axis as an extruder. Won't have it may happen in your case for your I don't know how you guys drive the extruder for the printing on the ABB with the turntable, but that's something that could be used. This is the external the axis data, so to have the name of each external, so A1 to A6. Then we enter into the actual post processor. So just like that. Here we have some default or default information. So here the speed, the default speed that we'll be using is 500 millimeters. So if, for example, you don't specify the speed, we will always use 500 millimeters. I do believe it should be that. No, we're just using it part of the header right now. So you need to have a set speed somewhere if you want to change the speed. Do I have anything else to show you here? So what I want to do next is show you a very simple post-processor that I created myself for one of my usage. I'm going to close that here, delete, and then here, in fact, I'm going to delete all of that, close, no save. I'm going to go ahead and pick a academic robot here. Like that. I'm gonna add a TCP to it. I'm gonna go down, create 1 frame, 2 frame, 3 frames, 4 frames from targets. Sorry, I'm going to saying Mecha program. And now select post processor. I have 2 post processors, so academic script and web interface. I'm gonna go for the web interface. Yes, I right click and then generate robot program with this one here. You will see it creates a simple text file that I can take and then bring to the web interface. And in fact, this one is a very simple one because academic is a bit special. They don't have a teach pendant. You just have a web interface. So if you want to program, you need to program through the web interface. So one of the easy way to load the program to their computer is to just open the web interface, create a text file here, simple.txt, and then pick that information, Control C and then Control V, that directly to the web interface, and then it will be loaded directly to the robot. So that works very well. So that makes a that creates a processor that is very, very simple. So let's go ahead and look into it. So do I have it here? I'm gonna go to GitHub, post academic script, or okay, I'm gonna go directly on GitHub to be sure that I got the right one. So log in here. I can go to post processor, can go to post, I can go to academic. I think it's the new one, so it must be the script one. It was updated 6 months ago, so that would make sense. Okay. Yeah, so okay, so this one will be simple to look at. So this is the academic script, this is the program that was generated, and I'm gonna open my temp here. I have the post Mecha program here. This one will be here. In fact, here, right click, split right. So that's how it goes. So we start from what we have from RoboDK, then it generates here, move J, move L, move L, and then we apply the script.py. So this one here is very simple as it's very short, and the last section here doesn't even matter. There's not a lot of information of, how can I say, there's not a lot of features in this one, but that's a good starting point. So first of all, we are just writing down in a text file, so that's fairly easy. So we have a program that is a .text. We don't even have a header in this case. We have a list here that we will call prog, in which we'll add the prog functionality. We decided we have 6 axes. in this case here, we do nothing when we have the start program because we don't care. We're just creating a text file. We don't do anything when you do the program finish in this case. And when the program save, I'm simply saving that as a txt file, and the program save will always happen at the end. So we have a program start, which will kind of trigger the process. So in this case, we just add nothing, and with the program finish, we add nothing too. But with the program save, we will save that as a text file here. What happened if we have a move? Oh, sorry, I'm just gonna go ahead here and look at the run message. So the first thing we do is go ahead and run a run message. So run message here is fairly simple. To add a comments, it's like /. So if it's just a normal run message, I will simply here, and it's always like if it's a comment. So in this case, it's true, and then it's true here. So those are both comments. So if comments equal true, self add line, add the little / space, close the string, then add done plus message, whatever message was entered here. So that will bring us the little like top section here. Then we'll go ahead and call a set frame. So I can go ahead and find the set frame here, fairly simple. We go ahead and set add line self set word reference frame. So this is how they call it. And then I'm adding a string here, and in that string I'm gonna add the pause, and I have a subroutine called pause to string. So if I can control F if I want, and def to find the definition. So def pause to string will simply take the pause, apply a transformation to it so that we have XYZ RPW, and then it will simply add those values in a string and will convert the radian to degrees, and will send us back the answer in the set frame. If I can find the set frame here. And then it will write down this simple line here, set frame with the numbers. Here the set frame is at 0. Then it will do the same with the set tool. So if we go ahead and look here, simple add line. If I was to look in the documentation of the Macademic for the set tool, this is the line that needs to be entered. So set tool reference frame, and then the XYZ, and then rotation. And then you have move J. So when you have a move J, you come here. This is move joint followed by the joint values. And if you have a move L, it's move lin followed by the joint values. So you have that here. There are some features that are not supported. So as you can see here, move C. I did not add move C because this robot do not support move C altogether. So there is no move C for them. There is no, in this case, the linear acceleration is not supported. So I don't know if it's because there is no acceleration or just because I did not program that part, but that could be a situation where we could want to add that acceleration. So what I need to do is go ahead, find the Macademic documentation, look at what a set joint act potentially, or set cart acceleration will look like with the value it requires. So in this case here, it's let's say if we set the Cartesian speed, so set Cartesian lin velocity, and it requires a float with 3 values after the decimal, and it must be between in this case it must be between 0 and 500. So we just go with take the minimum between the speed that RoboDK gives you and 500, because within RoboDK there's nothing preventing us to say that the robot can go to 1 meter per second, let's say, but that won't go through. So we just add kind of a filter here to make sure that, and we should have even like on top of that take max between, let's say, that and 0, so that we're sure that we don't have any negative value, and even like 0 is not a very good value for a speed. So we have here some set DO. So if it's a variable, we can just say out, and then the value here followed by, in fact, followed by true or false. So it will kind of set the right value at the right, in fact, the right output with the right number at the right state, which is either true or false. Zone data is out to set the blending here, so you can set a specific blending in millimeters. So this one is very simple. I like this one because it's really like straight to the point. There's not many conversion. I did this one like within an hour or so, so it's very, very, very simple. Yeah. So there's other more advanced stuff that I can show you if you want in a future video. I will let you decide if you want me to show you. We can trigger stuff within RoboDK using program calls so that the behavior of the post-processor change at different moment in the path. So let us know, let me know if it's something that you would be interested in. But for now, I do think that knowing what I showed you should be a very good starting point if you need to do some changes. To give you an idea what you could do with post-processor, let's say I'm gonna open up the UR post-processor. So it's gonna be the last thing I'm gonna show you. If you generate a program with the UR post-processor, you will always have, and you can change that, but you will always have a header with some example program in it. So here you can see you have a def spray on with some set standard digital out, set standard blah blah blah. You have a extruder here, you have a move axis here. So my point is that you can create some, let's say, snippet of code that you want to be added to all your programs so that you can refer to them directly from RoboDK. So from RoboDK, we could just call the program spray on and not do anything with spray on within RoboDK, but when the program is generated, as this is part of the header and it's always in your program, you can refer to it, you can call it at any moment. So that's a way to kind of facilitate the work of your end user so that they don't have to know about this subroutine or anything. They just need to call the right subroutine in the program, so potentially in the program events or just with a program call, and that will trigger that. In fact, it will create a program call, and that program call in the program will refer to that subroutine that is part of the header. So this way you kind of reduce the chances of error, and you can just have one specific post processor for each of your customer if it's needed, so that it generates exactly the code that this user needs. Okay, I hope it helped. That's it for this introduction to post processor modification.